We've talked about diffusion, which is the movement of molecules or ions to an area of lower concentration. That is a passive process. But we certainly need to also add osmosis to this discussion. And osmosis is nothing more than the diffusion of water molecules. So that means if osmosis is the diffusion of water molecules, it is the movement of water molecules to an area of lower molecular water concentration. If we look at this image right here, and a more complete definition of osmosis is the diffusion of water molecules via a semi-permeable membrane to an area of low molecular water concentration. And the selectively permeable membrane is important, and I'll get to that in a moment. Here we see water on both sides of this selectively permeable membrane. We have 6 water molecules on this side of the membrane and 6 water molecules on this side of the membrane. Keep in mind we're generally thinking of volume, but it's volume of water, but it's a bit challenging for me to articulate or display the volume with regards to the ratio of solutes. So I'm just showing 6 water molecules over here and 6 water molecules over here. There's a much higher concentration of water here than over on the right side. To be clear, this is 100% water on the left side of this membrane, and over here, the water here has become diluted by the presence of solutes. It doesn't matter what the solutes are. They could be glucose, they could be sodium, they could be bicarbonates. Just the fact that there are solutes within this side of the membrane informs us that this has a lower concentration of water molecules. As a result, water is going to move from the left to the right, from an area of higher molecular water concentration to an area of lower molecular water concentration. Now, what I was saying about the importance of the semi-permeable membrane is that it cannot be permeable, and take that with a grain of salt when I say it cannot. I'm not saying it's the end of the world, but I'm saying with regards to the definition of osmosis via a semi-permeable membrane, if this membrane were permeable to this solute, then the solute would start moving back and forth and equilibrate, so we have the same amount of solutes on the left as we do on the right. And in this image, if 2 of these solutes moved over here, then we would have the same water concentration on both sides. So that's why the understanding of a selectively permeable membrane is important. Now keep in mind, oftentimes within biology or within physiology, we often use the term, and I apologize for the vulgar language, that solutes suck. That is to say, water is always going to move to the area where there's more solutes. Water chases the solutes. The solutes are, if I do it this side, the solutes are drawing the water over towards themselves. Hence the term solutes suck. But it's not really, I think it's more important to understand the process rather than just that phrase. People can repeat that phrase over and over and over again, but they're not totally understanding what that means. So if we add more solutes to this side, okay, so I don't know how many solutes I've drawn here. I'm not going to count them because that would take time, but I hope we can all agree that there's more solutes, red solutes on the left side now than on the right. There's still the same amount of water molecules. You could think of it as the same volume of water. Water is now going to proceed from the right to the left because there's a higher solute concentration over here. So this goes back to understanding concentrations and osmolarity. Osmolarity is the measurement of the solute concentration in solution. The last thing I want to say about osmosis before we talk a little bit more about concentrations are how we define osmosis. So I could define osmosis 3 ways. I think I've already defined them at least 2. 1, osmosis is the diffusion of water molecules. And we could certainly put the semi-permeable membrane in there. So let's say the diffusion of water molecules across a semi-permeable membrane. 2, we could say it is the movement of water via semi-permeable membrane to an area of low molecular water concentration. That's water moving from an area of high molecular water concentration to an area of lower molecular water concentration. The third way we could define osmosis is the movement of water to an area of higher solute concentration. And that's really where that term solute suck comes from. Water is moving to an area of higher solute concentration. Keep in mind, osmosis is a passive process. And I know we've talked about diffusion being passive, moving from high to low. And it's the same thing with osmosis. So I don't want you to get caught up in me saying that water is moving to an area of higher solute concentration. It certainly is, but all the high solute concentration is telling us is that, in this case, on the left, that there's a lower molecular water concentration. Let's take a look at concentrations, because I know I've used that term a lot, and sometimes that's hard to grasp. The example I love to use for it is chocolate milk, or more specifically Ovaltine. Not everyone knows what Ovaltine is. I think it's better than pure chocolate milk. I prefer the malt flavored Ovaltine, but it doesn't really matter. The main reason I like to use the example of Ovaltine is the granules of Ovaltine are much larger than that of regular powdered chocolate milk, where you can actually see the grains of the chocolate. But we have 2 glasses of milk right here. The same volume of milk. If we're thinking about the body, it's the same volume of water. But we have the same volume of milk here. I don't know what the volume is, but let's say it's 8 fluid ounces. We have added 1 scoop of Ovaltine to this cup and 2 scoops to that cup. The right side, the cup on the right side here, is more highly concentrated in Ovaltine, or in the chocolate, than this side, because this has 2 scoops, this only has 1. It's the same volume of milk. That's why this side is darker than that side. But even though this has a lower concentration of chocolate, or the solutes, it has a higher concentration of the milk. And this has a lower milk concentration because it has been diluted by all of these solutes. So if we go back here, these solutes are diluting the water, and that's going to tell us or inform us the direction water is going to move. Another way to look at this is if we have that normal glass right here, this should be the same volume as up here. 1 scoop going into this glass, just like here. Now we have a shot glass of milk. I don't know how many fluid ounces within a shot glass, but let's say it's 2 and 1 scoop. So we're adding the same amount of solutes to both of these, but there's a much higher concentration of the solutes here than over here. And there's also going to be a higher concentration of milk here because there's more milk in relation to the solutes. So when we're thinking about concentration, and concentration is important to understand with regards to osmolarity and with regards to osmosis, when we're thinking about concentration, we need to think about the volume of the solvent, which is water, versus the amount of solutes in that solution. Now, how can we apply this or understand this to normal human physiology, or specifically pathophysiology? We've talked about diabetes. Diabetes mellitus is an issue with insulin that's released from the pancreatic beta cells. We've talked about insulin being required for glucose uptake. There's 2 types of diabetes, or 2 main types. There's more than 2 types. Type 1 and type 2 diabetes. Type 1 diabetes is an autoimmune disease that results from our immune system attacking the islets of Langerhans, or specifically the beta cells of our pancreas. So there's a much lower diminished levels of insulin in the body, and not enough for our insulin-dependent cells to uptake glucose. And that's a problem for the insulin-dependent cells downstream that need that insulin for glucose uptake. Type 2 diabetes, as we've talked about, is more of a lifestyle issue. That is to say, poor diet and lack of exercise. So there are chronically high levels of glucose in the blood. If there's chronically high levels of glucose in the blood, that means also that there's going to be chronically high levels of insulin. And that becomes the baseline for the body. And then the insulin-dependent cells downstream become resistant to that insulin because that's now the new baseline, and they're not reacting to that insulin. They're not opening up those glucose channels, and glucose uptake is not happening as readily as it should. So if glucose uptake is not happening in untreated diabetics, what happens to that glucose? Well, that glucose is going to end up getting filtered out of the blood in the kidneys, specifically within structures known as nephrons, and the glucose is going to end up in our urine. Glucose is a solute, so if there is a ton of glucose moving in our filtrate, which is the substance that's kind of halfway between, or an intermediate step between the blood plasma and the urine, if there's a bunch of glucose in the filtrate and also in the urine, what is going to want to chase that glucose into the urine? It's going to be water, because solutes suck. So water is going to chase all of that glucose into the urine, and that's why many, maybe all untreated diabetics are constantly urinating, because that glucose is not moving into the body cells, rather it's moving into our urine, and one is peeing a lot. So osmosis is super important, understanding concentrations, and we'll talk more about this as we move forward.